Today we are doing heat and temperature. So the first question here, let's say, what's the difference between heat and temperature? What is the difference between heat and temperature? It's between heat and temperature. So what's the difference between heat and temperature? That's a deeper view. Okay. So here the simple difference between heat and temperature is this. So see, heat is a cause, while temperature is the effect. Okay? Heat is a cause, while temperature is an effect. Let's talk about this one here. So heat is a form of energy. Heat is a form of energy. Is a form of energy. While temperature is the measure of hotness or coldness. Okay? Heat is just a form of energy, while temperature is just a measure of hotness or coldness here. Okay. So I think these are the simple differences between heat and temperature. So heat is just a cause, while temperature is the effect of heat. Okay. So let's go to question number 2 here. Let's go to question number 2 here. What is the difference? What's the difference between heat capacity and specific heat capacity? Okay. So what is the difference between heat capacity and specific heat capacity? So what's the difference here between heat capacity and specific heat capacity? Okay. So here, let's say heat capacity is the heat required. So heat required. Okay. Heat capacity of a body or substance, just the heat required to raise its temperature by, let's say, 1 degree Celsius or Kelvin without changing its state. Without change of state. Without change of state. So heat capacity is the heat required to raise its, or heat capacity of a body is the heat required to raise its temperature by 1 degree Celsius or Kelvin without change of what? Without change of state. Okay. So here the units here, let's go for the units can be joules per degree Celsius or joules per Kelvin. So these are the units for heat capacity. What about specific heat capacity? What about specific heat capacity? So, wow, specific heat capacity, let me put it here. Specific heat capacity, specific heat capacity is the heat energy, is the heat required to raise 1 kg of a substance, 1 kg of a substance through 1 degree or through a degree, through 1 degree without changing its what? State. Without changing its state. Without changing its state. So specific heat capacity of a body, the heat required to raise 1 kg of a substance, 1 kg of a substance, we put of a substance here, of a substance, okay, is the heat required to raise 1 kg of a substance through a degree or 1 degree without changing its state. So this is the difference between heat capacity and specific heat capacity. You are also. Eh?
Yes, you said that is what?
So the question is here, what is the difference between heat capacity and specific heat capacity? When we say heat capacity is the heat required to raise, heat capacity of a body is the heat required to raise its temperature by 1 degree of Kelvin without changing its state. While specific heat capacity, the heat is the heat energy required to raise 1 kg of a substance through a degree or through 1 degree without changing its state. Yes, you lost. Yeah, still lost. Okay. Let's talk about heat transfer here. So 1, 2, 3. Explain 3 ways in which heat can be transferred, which heat and water transferred or transferred. So explain 3 ways in which heat and water can be transferred. So how many ways can heat be transferred? Heat can be transferred by what? By conduction, convection, and what? And radiation. So let me list them out. So number 1 is saying heat can be transferred by what? Conduction. Okay. Let me explain this one. So what do you mean by conduction here? What do you mean by conduction here? Okay. So heat transfer and conduction happens this way, or in a material, by moving from one point to another. So heat transfer in this form happens in a material by moving from one material to another. So this one happens by moving from one material to another. 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 The material itself as a conductor. Okay. So this one happens in material by moving from one point to another, from one material to another. The material itself serving as a what? As a conductor. Okay? one point to another, or from one material to another, the material itself serving as what? As a conductor. Or this one can take place in materials or bodies, in objects. Okay, so in objects, not in actual contact. In objects, in actual contact. In actual contact. Or this can take place in objects in actual contact by moving from one point to another. Okay. So number two, let's talk about what? Convection. How is heat transferred by convection? So here heat is transmitted by the actual movement of hot fluids. Let's say liquid and gas, liquid or gas, causing convectional currents. Convectional currents. Okay, so convection heat is transmitted by the actual movement of hot fluids, liquid and gas, causing convectional currents. Okay, so let's go to the third one here. The third one is what? Is the radiation. How is heat transferred? Through radiation. So we'll talk about this heat transfer through what? Empty spaces. Heat is what is transferred through empty spaces. Empty spaces, let's say vacuum. So these are the three ways in which heat can be transferred or moved from one place to another. Now let's talk about effects of heat. Effects of heat. Effects of what? Heat. Let's talk about effects of heat. Effects of heat. So when you heat an object, what happens when you heat an object? What happens when you heat an object? So the first thing, this temperature will do what? Will rise in temperature. Okay, rise in temperature. One. Number two, you have change of color there. Change in pressure. Change in pressure provided temperature temperature is constant there. Okay? Just change in dimensions. Some of them will expand, contract, change in dimensions. Change in physical state. Change of physical state. We also have electrical changes. So chemical changes. Okay, so I'll try to explain all of this. So the first one effect of heat is rise in temperature. The temperature rise, change in color, change in pressure, change in dimensions, change in physical state, electrical changes, chemical changes. So these are the effects or the result of heat. When you heat something, these are the results. Okay. So what was that question? Question number 5. What is sensible heat? So what is sensible heat? What is sensible heat? What is sensible heat? Okay. So sensible heat is the amount of heat energy required to cause a rise or fall in temperature. The amount of heat energy required to cause a what? Cause a rise or a fall in temperature of a substance. Okay. So sensible heat is just the amount of heat energy required to cause a rise or a fall in temperature of a substance. So, and what is the formula for sensible heat? So we know that heat is given by delta Q equals to the mass of that substance multiplied by the specific capacity of that substance multiplied by what? The change in temperature of that substance. Okay? The change in what? The change in temperature. So this is the formula of what for sensible heat. Okay. So sensible heat, which is Q, is equal to what? The mass of that substance. It says this is the mass. And what is this? This is the what? The specific heat capacity of that substance. Specific heat capacity. The specific heat capacity, the what? And this whole thing, the what? The change in temperature. Change in temperature. Okay. So this is the formula for what? For sensible heat. This is number 6 here. Number 6. What is latent heat? What is latent heat? What is latent heat? What is latent heat? People are looking at me. What is latent heat? What is latent heat? So latent heat is the amount of heat energy required to change the what? To change the state of a substance by changing its temperature. The amount of heat energy required to change the state of a substance without changing its temperature. The amount of heat energy. The amount of heat energy. Heat energy required change the state of a substance, to change the state or the state of a substance, without changing its temperature. Without changing its temperature. Changing its temperature. Okay. So this is just the amount of heat energy required to change the state of a substance without changing its temperature. That's what we call the latent heat. So two forms of this latent heat, or two types of this latent heat. So the first one, we say 7 here. 7 here. What is latent heat of fusion? What is latent heat of fusion? Latent heat. Okay, so what is latent heat of fusion there? What is latent heat of fusion? So this is the amount of heat energy required to change the state of a substance from a solid to a liquid or vice versa. So the amount of heat energy, the amount of heat energy, required to change the state of a substance, from a solid to a liquid, from a solid to a liquid, or how do I do it vice versa? So it's just the amount of heat energy required to change the state of a substance from a solid to a liquid or vice versa. Okay. Number 8 here. What is latent heat of vaporization? What is latent heat of vaporization here? What is latent heat of vaporization? What is latent heat of vaporization there? So, if this one is changing the state from solid to liquid, what about this latent heat of vaporization here? So this one will change from solid to what? To a gas or a vapor. Okay? The amount of heat energy, the amount of heat energy required to change the state of a substance, the state from where? From a liquid to gas or to vapor or gas, vapor or vice versa. Can be vapor or gas or vice versa there. So here on this latent heat, we have a formula for this latent heat. And what is the formula for this latent heat? So what is the formula for the latent heat? This is the formula for sensible heat. And the latent heat has got its own formula here. So the formula for latent heat is this one. Latent heat, which is Q. Latent heat. Let me put a L here to write latent heat. Latent heat is equal to what? The mass multiplied by the latent heat, right? So the mass multiplied by the what? The latent heat. The mass multiplied by the what? The latent heat. The latent heat. So in some formulas, sometimes you see, like after L, they'll put a V here, sometimes they'll put an F here. So if you have like a V here, meaning the what? The latent heat of what? Vaporization. If you have an F here, meaning the mean latent heat of what? Fusion. Right? Fusion. So the total heat energy in a substance, the total heat energy in a substance is equal to the what? The latent heat plus the what? Plus the sensible heat. The latent heat plus the what? Plus the sensible heat. Okay? Okay, so how do you know which formula to use in the equation on heat and temperature? How do you know? Because we have two formulas, of the formula for what? For latent heat and of the formula for sensible heat. How do you know? So you can know by what? By definition. So we said sensible heat is the amount of heat energy required to cause a rise or a fall what? In temperature. The moment in the question you see where there is a rise in temperature, the moment you see the word rise in temperature or fall in temperature, just know that you are using the formula for what? For sensible heat. You don't just use any formula. The moment you just see the word rise or fall in temperature, just know that it's what? Is sensible heat. Okay. We do temperature conversion before we answer the question. Temperature conversions. How do I write the word conversion? This one? This one? Oh. Okay. So temperature is measured in what? Temperature is measured in what? Answer. Temperature is measured in what? What about you? Degrees or Kelvin? What about Frida? The same answer. So temperature is measured in Celsius, which is degrees. It's measured in Kelvin. It's also measured in what? In Fahrenheit. In America and USA, they still use Fahrenheit. Okay. They still use them. They still use Fahrenheit. You don't know Fahrenheit. So let's do temperature conversion between degrees and Fahrenheit. There. Let's do temperature conversions between Fahrenheit there. So let's do temperature conversions here. So, if you want to convert from degrees to what? To Fahrenheit. So which formula do you use when you are converting from degrees to what? To Fahrenheit. So it's a formula saying temperature, this small t means temperature in what? In Fahrenheit. So this T represents temperature. So temperature in Fahrenheit is equal to what? 9 over what? 5. Let me say. Okay, let me say. C plus what? Plus what? Plus 32. So it's temperature in Celsius degrees, right? So say temperature in Fahrenheit is equal to what? 9 over 5 open. Temperature in Celsius degrees plus what? Plus 32. So what is the meaning of this? For example, maybe I told to convert maybe 30 degrees Celsius to what? To Fahrenheit. To Fahrenheit. So convert 30 degrees Celsius to Fahrenheit. So what do? You just get this state, you put it where there's a C here, when you do the mathematics. The answer will be what? The answer will be Fahrenheit. So just put this state here. When you add them, then 9 over 5, that will be the answer. Okay? So So this is the first formula here. You have to know it. Number 2. What about this is number 1 here. What about temperature? Temperature in what? In Celsius degrees then is equals to what? So these do interchange. This one will go up and the other one will go down. So it will be 5 over what? 9. Okay? 5 over 9, when you say F minus 82. Okay? So temperature in Celsius degrees equals to 5 over 9. F, which is temperature in Fahrenheit, is minus what? 32. So this is the second formula here. So you have to know these, right? You have to know them. But they are simple if you just master them. So for, like here, if you want to convert temperature from Fahrenheit to Celsius degrees, if you are given 20 Fahrenheit, you just put it here, subtract, then you just multiply. Okay. Thermal expansion. Okay. What is the coefficient of linear expansion? What is the coefficient of linear expansion? Coefficient of linear expansion. So what is the coefficient of linear expansion?
Even though they are not given you the numbers to put any number there.
They will give you the number, I can't guess. If you are converting here, they will give you a number to convert this one to this one. You don't just guess, they will give you a number. So what is the coefficient of linear expansion? So the coefficient of linear expansion is just a number that denotes the degree of what expansion. So a number that denotes the degree of expansion. Yeah. So what is the coefficient of linear expansion? Just a number that denotes the degree of what expansion, right? Degree of expansion. Okay. So 10. So we don't waste time. Just go there to answer the questions. 10. 10 here. List down 3 types of linear expansion. List down 3 types of linear expansion. Down 3 types of linear expansion. So what are the 3 types of linear expansion? What are the 3 types of linear expansion? What are the 3 types of expansion? Remember, first is that types of expansion. These 3 types of expansion. So 3 types of expansion. Number 1, what is linear expansion? Linear expansion. Linear expansion. Number 2, superficial expansion. Superficial expansion. This is for the area there. This one is for the area. Superficial expansion. Number 3, what is the volume expansion, but it's cubical expansion there. Cubical expansion. The what? The volume. Okay. So now we're done for the definitions. We can answer questions. Now we've got our exam questions. Okay. So let's solve this question. So a cooling system on a vehicle contains 5 liters of water. What was it? A temperature at a temperature of at a temperature of 16 degrees Celsius. How much heat is required to raise the water temperature to 96 degrees Celsius? Take the specific heat capacity for water to be what? 4,200 joules per kg Kelvin. Okay. So solution. So here the first thing we need to understand is this. So what is the formula for what type of formula do we use here? Because of this way, because there's a rise or fall in temperature, the moment you see the weight rise, meaning you're using what? Sensible heat. So we need to introduce the formula for what? For sensible heat, which is Q is equals to what? Mass multiplied by specific heat capacity times the what? The change in temperature, T2 minus what? T1. Okay. But if you observe in this question, we are not given the what? The mass. We are not given the what? The mass. So what we need to do is 1 liter of water is equals to 1 kg. Right? So 1 liter of water equals to what? To 1 kg. So meaning this 5 kg is equals to how many? This 5 liters is equals to how many? So 5 liters is what? 5 kg. So here the mass that we are talking about is what? Is 5 kg. 1 liter of water equals to what? 1 kg. So in this case we are talking about what? 5 kg. Okay? So meaning here, we are talking about the what? The 5 kg. 1 liter of water is 1 kg. So you can write it in your book somewhere. 1 liter of water is equals to 1 kg. So meaning there 5 liters is equals to how many? Is equal to 5 kg there. Okay? So meaning, let's say data. Let's put data somewhere here. So let's put data. Let's see what we are given. So let's say data. Let's say data. What are we given in the question? We are given the mass size. So say the mass in that case equals what? 5 kg. Yes. You know about the specific capacity C? We are given here which is what? 4,200 joules per kg Kelvin. Okay? What else are we given here? Temperature. So I given the change in temperature. So change in temperature. Change in temperature goes to the final temperature minus the what? The initial temperature. Which is the final temperature here? So the moment you see the weight 2, meaning it's the final temperature. At means the initial. 2 means the final temperature will be 92 minus what? 96 minus what? Minus what? Minus 16. That's the change in temperature. So we have everything now, just a matter of replacing in our formula. Just a matter of what putting them in our formula. So let's say sensible heat is equals to what? What is the mass? 5 kg. Multiplied by what's the specific capacity? 4,200. Multiplied by what is the change in temperature? What is 96 minus 16? 80. So multiplied by what? By 80. What's the final answer when you do the mathematics? And what are the units? What are the units for heat energy? What are the units for heat energy? What are the units for heat energy? It's joules. So what's the answer? 1,600. So let's say not video anymore. It's other please. T joules G. So this is the answer. Is 1,600,080 chachama. So that was the answer. It's simple. Yes. That was simple. Yes, She just tried to complicate. Tell you what is saying. That we should understand when you stepped out. What do you understand you stepped out? Yes? Martin, you know, it's quite a venue. That's what a venue. Okay, so question 2 here. A block of copper of mass 2 kg has a temperature of 20 degrees Celsius. So what will be the temperature of the block after it has received heat energy of 240 kilojoules? Take the specific capacity of copper to what? 400 joules per kg Kelvin. Okay? So how do we answer this question? So we don't know the final what? The temperature. So here they want us to find the final what? The final temperature. So we bring that same formula for sensible heat. We bring the formula for sensible heat of the solution here. The formula for sensible heat, which is Q is equals to what? Mass multiplied by the what? The specific capacity of the what? The change in temperature. T1 minus what? T2. We know this formula. So again, in this question, they want us to find which T. So what will be the temperature of the block after? So they want to find what? T2 here. So we look for a way of making T2 the subject of what? Formula. So how do we make T2 the subject of formula then? How do we make T2 the subject of formula then? So the first thing, if we want to make T2 the subject of formula, we can eliminate this with what? Without T. So we can divide both sides with what? MC, because we want to remain with my T. Even this side we divide with what? With MC. So this and this will cancel here. So meaning we remain with what? T2, let me put direct. T2 minus what? T1 is equal to what? Q over MCI. One more. Any question? So what's next here? I want to remain with this T2 here. So meaning this one, this T1 will go the other side, so I want to remain with T2. So it will be T2 is equal to what? Q, which is the heat energy, MC. Then this one is supposed to be when it jumps, if it's negative, when it jumps here to what? So it will be plus T1. Yeah. If it's simple. If it's simple. But here, you have seen that this energy is given in what? In kilojoules. So we have to take it to what? To joules. So how do you take this one to joules? How do you take this one to joules? Do you all know how to convert? Okay. So you can use this formula here to convert to say given value times 10 to the power g minus what? I. So this is the formula that we use here to convert. So say given value. So and again to use this formula, you have to understand the prefixes, right? You have to understand the prefixes. So we are coming from what? Let's say 240. This 240 kilojoules to what? To joules here. So what's the meaning of this G here? This G represents the first letter here, which is K. What about this other here? Represents the first letter this other side here. And anything that is not part of the prefixes is 0. Joules is not part of the prefixes, right? The prefixes are those things you see: centi, milli, deca, deci, hectare, chamchano. Those are the prefixes, right? So he'll say, what is the given value in this case? So say 240 multiplied by 10 to the power, what is this G? What is the first letter here? Kilo. What is kilo? Kilo is 10 to the power 3. So to the power 3, then minus, what is R here? The first letter here, joules. Is joules part of the prefixes? No, so you put a 0 in front. Okay? So meaning the answer will be 240 multiplied by 10 to the power 3 joules. So when you pass this direct on the calculator, what is this? This is 240 times 1000 here. Which is 240,009 joules. How many? We did conversions with you. Did we do conversions?
No.
We did that? No. Yeah, we did do conversions. Don't accuse me. You update me. So let me do this part time. So we are watching 240,000 joules. So now just a matter of replacing the values there. Just a matter of replacing the values there. So says T2 is equals to what? T2 is equals to what is the energy? The energy is what? 2,000. Okay, 240,000 joules. plus what is the temperature? 20 over what is the mass? 2 multiplied by what is the specific capacity? 400. Okay. So now what is the answer? So multiply, what is 2 multiplied by this one? 800. So this one will be T2 is equals to 240,000 divided by 800 plus what? 20. So what is 240,000 divided by 800? What is 240,000 divided by 800? 300 plus 20. So it will be T2 is equals to 300 plus what? 20. So what is the final answer? T2 is equals to what? 320 degrees what? Celsius. As simple as that, right? As simple as that. Questions on temperature are simple and straightforward, right? I read it. You are not answering. Now you are stopped answering. Okay. So let's answer the next question. We still have 4 questions. So a block of steel of mass 2 kg at 800 Celsius degrees is plugged into a mass of 4 kg of water at 15 degrees Celsius. If the heat losses to the environment are neglected, what is the final temperature of the steel and water? The specific capacity of water is 4.2 kilojoules per kg Kelvin, and C of steel equals to 0.48 kg per kg Kelvin. Okay. So in this question, on this type of the question here, we say heat lost is equal to what? To heat gained here. Okay. So it's more like you're putting the mass of another substance into the other substance side. You're putting the mass of another substance into another what? Another substance there. So it's more like you're putting a hot substance into water. You're putting a hot substance into water. You're putting the other substance into the other substance. Okay. So for example, if you have maybe, let's say you have a hot pan or anything hot, you have a hot pan, then you put it in water. What will happen to that pan? You have a hot pan, you put it in water. What will happen to that pan? It will lose heat, It will lose heat. And what will gain heat? The water will gain heat, The water will gain heat. So here we use what we call the conservation of what? Of heat energy. We use the conservation of heat energy here. We use what we call the conservation of heat energy, not the conservation of energy, where you say heat can neither be created or destroyed, something like that. So, but here we're talking about the conservation of heat what? Heat energy. Heat lost is equal to what? Heat what? Gained here. Heat lost is equal to what? Heat gained. So say heat lost is equal to what? Heat what? Heat gained here. Okay. Heat gained here. So here they're asking us to find the final temperature of the steel and water. Just imagine, you get the steel. Maybe the steel is hot. You get the hot steel there, you put it in water. When you put it in water, meaning steel will lose what? Heat to the what? To the water. And because the steel and the water, they are together in water there. Steel, they are together with water now. So meaning they have what? One final temperature. Because they are together. So meaning here we only need one temperature here. We only need one final temperature. Because they are together, meaning they have the what? The final temperature here. Right? So, and the temperature that we are talking about here should be between 800 and 15 degrees, right? The answer that you should get here should be between 15 degrees Celsius and what? And what? 800 degrees Celsius, yeah? So which one is losing there and which one is gaining there? Which one is losing and which one is gaining there? Between water and steel, which one is losing and which one is gaining? Steel is losing there. Then steel is losing heat energy to water. So meaning water is what? Is gaining. So So meaning this side we put what? Still, which is losing. This side we put water, which is what? Gaining. But here we see that there's a rise or a fall in temperature. Because we don't know the temperature that we'll get, so meaning we use the what? The sense for heat. Right? We use the sense for heat. So here it will be, what the formula? It will be the mass multiplied by what? The specific heat capacity. But the trick when you're finding this question is this. On this one which is losing here, it will be T1 minus what? T2, not T2 minus T1. Right? This is just the trick here. It will be T1 minus what? T2. B equal to what? On this one which is gaining, it will be the mass of water multiplied by the specific heat capacity of water, then T2 minus what? T1. And here what are we finding there? We are finding what? T2, because that's the final temperature. So the trick is on this one. If you just interchange, you put T2 here, T1 this side, you answer on the correct time. So on this one which is losing, it to be T1 minus what? Minus T2 here. So this side of what is Ty? And here of what? Water. Okay. So what is the mass of steel then? What's the mass of steel? 2. What is the specific capacity of steel?
0.48.
0.48, right? And this one is given in what? In kilojoules. So we can take it what? To joules. So how do you take that one to joules then? From kilojoules to joules, how do you do? So you multiply by what? By 1,000, like what we did there. Then you multiply by what? 1,000. So multiply this 0.48 multiplied by 1,000. So meaning the answer being joules per kg Kelvin. What's the answer? You're comparing. 480. 480 joules per kg Kelvin. Always, when you're given in kilojoules here, take them to what? To joules. And how do you take them to joules? Just if they're in kilo, just multiply by 1,000. Then, what is T1 there? What is the T1 of steel? So let's say that at means the initial temperature is T1. So the T1 of steel is what? 800. So say 800 minus what? T2, we don't know. Then because what is the mass of water? 4. What is the specific capacity of water?
4.2.
I told you to always convert them to what? To joules. So that one is what? In kilojoules per kg Kelvin. So you need to take it to what? So that will go what? Mm-hmm. 4.2 times 1,000.
Battery.
Okay, but it's recording. Eh?
Yes.
It's recording.
Yes.
Okay.
But you can. I do close. 4.0.
Go on saver mode.
It's not doing.
It's recording.
Yes.
If it's not recording, it will beat you. Okay, so 4 times, what's the answer there? 4.2 times 1,000. 4.2. What's the answer? 4.2 times 1,000. It is 4,200. So to what times what? 4,200 here. Then multiplied by what is T2? We don't know. Minus what is T1 of this? It's 59. Yeah. Okay. So here, there are a lot of mathematics you can use. You can multiply this one by this one, then you multiply through what else. But let's use this mathematics here. Let's use this mathematics here, we see. And this one will be quick. So, because our main goal want to remain with Bama TTI. So these values, 4 times 400, 4,200 and that one here, they are confusing us. So we can eliminate them. How do you eliminate them? You divide both sides with the same number. 80. Even this side you divide. Who's confused? But the answers will be the same.
The answers are just the same. Just make the mistake
on the number. same one? They won't be the same one?
No, no.
Yeah. So it will divide by 960. 960. That's now what I got there. Divided by was 960. So the answer is 17.5. 17.5 T2 minus what? 15 degrees, right? Yeah, 17.5. Okay, so I've seen how it's simplified there. So from here, just say 800 minus T2 is equals to this one and this one, 17.5 T2 minus what is 17.5 times 15? 17.5 times 15 is 262.5. 262.5. Then from here you can group the right terms. So this one can come the other side to be negative T2 minus 17.5 T2 is equals to what? T negative 262.5. Then this one will jump over minus 800. Okay? Minus 800 there. So let me bring it here. So what is the answer here? So this one to be negative 18.5. T2 is equals to what the answer here? So minus you are confused. Okay. This is cool. 0.5. We want to make
How have you done to come up with that one negative 18.5?
it's cool. T2 is equal to what? Divide by negative. So the answer here is 57.4 degrees Celsius. Over. This was the answer, 57.4 degrees Celsius, right? So you're asking me how I got this value. Here, this just same as negative 1 minus 17.5. Negative 1 minus 17.5, which is what? Negative 18.5, right? Then this negative 262.5 minus 800. So that was the answer there. Then you just divide, so that will be the answer there. You are lost? Eh? You are talking to your boyfriend. Some boyfriend will teach you. When you class, you're talking to your boyfriend. He will teach you. You explain.
Just explain.
Come my madam in class. So
I will say that I'm in class.
You explain. You told me that you are single. Then I'm talking to your boyfriend. You explain. Eh? I should explain. Hi, Frida. Hi. Your boyfriend will explain.
Image tattoo 5.6 area. Hello, you're telling.
Put it in by. What is negative 662.5 minus 800? Negative 662.5 minus 800.
262.5 minus 800. Oh, I have no problem. Hello, 18. 18 point.
Negative 1 minus You are not roasted? You are never good cake. Not this one. We'll take it, you're right.